Let's go over this problem. F of x equals x cubed minus 12x to the second plus 36x. We need to identify the intervals where the graph is increasing and decreasing when it's concave up and concave down using the second derivative, and find the absolute maximum and the absolute minimum. Let's get started. F of x equals x cubed minus 12x to the second plus 36x. Part A, to find the open intervals where the function is increasing and decreasing, we'll be using f prime. For part B, to find the open intervals where the graph is concave up and concave down, we'll be using the second derivative. For part C, use the extreme value theorem to find the absolute maximum and the absolute minimum on the closed interval from -1 to 7. We will be comparing the maximum values and the minimum values with the end points max and min or values. So we'll be finding f of -1, f of 7, and compare those to what we found in part A. For part A, to find the open intervals where the function is increasing and decreasing, before I get started with f prime, let's go over f of x. As you can see on the left side, we're gonna factor it out because I could see that it has x in all of them. So let's take x out as a common factor. This equals x multiplied by x to the second minus 12x plus 36, which is also could be factored what's inside to the following: x times x minus 6 times x minus 6. Setting this equal to 0 will give me two roots or two x values. So we have x equals 0 and x equals 6. Those are called the x-intercepts. For the function f of x, as you could see, we have the following. At x equals 0, the function value is 0, and at x equals 6, the function value is 0. That's something that will help us graph at the bottom right side, as you could see. For f prime, finding the first derivative of a polynomial, we'll take it term by term. So x cubed, to find the derivative, will bring 3 up front, and the exponent becomes 3 minus 1, which is 2. So we have 3 x to the second minus 2 comes down next to 12, makes it 24 x, and the last term gives me 36. Let's factor 3 out. So we have 3 multiplied by x to the second minus 8x plus 12. The inside part is a polynomial of second degree that is factorable. That's gonna give me 3 multiplied by x times x will give me x to the second. 12 will be 6 times 2, give me the 8 in the middle. So I'm not going to pick 12 and 1 or 3 and 4. We'll pick 6 and 2. 6 and 2. Of course, we can't use plus plus to get the minus 8. So we have to get minus or use minus and minus. So for f prime line and information, we have 3 roots or 2 roots at x equals 2 and at x equals 6. Let me take this square away. Let's go back and try to get just the 2. So we'll put this as plus 12, and this will be x not x squared minus 6. So we have f prime at x equals 2 is 0, and at x equals 6 is 0. That's when you try to find the roots or the zeros of f prime. You'll get 2 and 6. Now plug in numbers to the left of 2 between 2 and 6 and greater than 6 to find the signs of f prime. I have the following. It's a plus on the left, minus in between, and positive at the right side. So the graph should be increasing here, decreasing, then back increasing. To answer the first part, part A, we will write on the right side that the graph is increasing. Let's write it here. On negative infinity to 2 union 6 to infinity, and will be decreasing on the interval from 2 to 6, the open interval from 2 to 6. Part B. We will need to find the second derivative. So the second derivative, looking at the first derivative on top, this is the first derivative, and we need to find the second derivative now. For the second derivative, f double prime of x will give me 3x to the second becomes 6x, minus 24x will give me minus 24, and plus 36 will give me 0. Factor 6 out, that will give me 6 multiplied by x minus 4, setting this equal to 0, that will give me x equals 4. So for the second derivative line or information, at x equals 4, the second derivative value is 0. Plug in numbers on the left and right of 4 to find the sign of second derivative. I have a negative on the left, positive on the right side, which means concave up on the right and concave down on the left. To write it down, let's go to the right side. So the function is concave down on negative infinity to 4, and concave up on 4 to infinity. Next, to find the extreme value, or use the extreme value theorem to find the absolute maximum and minimum, I made a small table on the left so I could organize my thoughts and finish it and graph it on the right side. So we have all the way at the left, that's my endpoint, this right here. I will use -1. Plug in -1 in the function, I get minus 49. That's an endpoint. So this is an end point. We need it anyway. Next, I'm going to use 0 for x, and that is this right here. 0 gives me 0. So we have 0 equals 0, which is an x and also y intercept. Let's mark this on the graph before we lose it. That's a 0, 0 right here. Next, I used the number 2 because after absolute maximum we will have at x equals 2. We have a max point at 2. As you could see from right here, that's a max. Increasing then decreasing, that will give me a max. So we need the 2 to use, and plugging in 2 in the function, I have 30, 32. So this is a max point, since f prime tells me that there's a max at 2. Next, let's use the point 4, or x equals 4, and that is this right here. This point is an inflection point. Plugging 4 in the function, I do have 16, and that is an inflection point. Next, I used the number 6. The number 6 tells me from this right here that we have a minimum at 6. So we have a minimum right here when x equals 6. Plugging 6 in the function, I have 0. So we have a minimum at x equals 6. Finally, an endpoint at x equals 7. That's this point right here. The value of the function is also 7. And that's an endpoint. Now, comparing the values, we have the following. This right here is the absolute max, and this right here will be the absolute min. That's for part C. To do a quick sketch, I have by hand the following. The graph goes from -1, -49 all the way down, somewhere here. Goes through the origin, reaches to 32. Let's take this back and make it a curve. Goes back down to 60, bounces back up and stops right here. One more time. So this point is 2. Let's point to them. It's hard to write all of them next to the graph. 2 and 32. That's the absolute max. This point right here is the inflection point, which is 4 and 16. This point right here is an x-intercept, which is on the table. I'm writing it down. X-intercept, 6 and 0. So this point here is 6 and 0, which is x-intercept. This point right here is an endpoint, and that is 7 and 7. And another endpoint all the way to the left is -1 and -49. So the absolute max and absolute min happens at these points. That's the absolute max, and that's the absolute min. And that should do it. For the table, to make it complete, I have absolute min and the absolute max at 232. 7 is just an endpoint. It's not a local max or absolute max, and that should do it.
Thank you for watching. If you like this video,
hit the like button and subscribe, and I'll see you next time. Thank you.